to recommend you to go for the first video, watch it completely till the last question, then you go along with this. Okay, I'm giving that link of the first video in the description. Okay, let us start. It's kind of level 2, if you wish to say like that, level 2. It's nothing like that, but still. So let us take one question: x square minus 5 mod of x plus 6 equal to 0. To solve this, it can be done in two ways. So I'm taking both the method 1 and method 2. Method 1, obviously, x square can be written as mod of x square minus 5 mod of x plus 6 equal to 0. Modulus of x equal, as soon as y, it will become a quadratic equation. Y square minus 5y plus 6 give rise to two factors, y minus 3 and y minus 2 equal to 0. Y we have chosen as modulus of x, so modulus of x equal to 3 or modulus of x equal to 2. So ultimately the answers are x belongs to minus 3, minus 2, 2 and 3. So 4 solutions basically. Now this second method, this method 2, I want you to do this question in this way. Sorry, that's method 2. This is the graphical method again. So what we'll do, x square minus 5 mod of x plus 6 equal to 0. This can be written as mod of x square minus 5 mod of x plus 6 equal to 0. Now we know how to draw the graph of x square minus 5x plus 6, right? The quadratic polynomial. It has got two roots, and the roots are, what do we call it, 2 and 3. So 2 and 3. So the graph of x square minus 5x plus 6 will be something like this. This is the graph of x square minus 5x plus 6 equal to 0 equal to y. So y equal to x square minus 5x plus 6. What we are looking at? We are looking at the graph of modulus of x square minus 5 modulus of x plus 6 equal to 0. Right? So let's say that if I consider this one to be fx, and if I wish to use this transformation f of mod of x, which is exactly this. If I consider this one to be fx, and if I wish to transform f of modulus of x, which is this, and we are looking for this, and we know how this transformation works in graph, right? What we do? We neglect that portion of the graph which is lying on the left side of y-axis of fx, and we take the mirror image on y-axis. So this is what it will look like. Now this graph, this new graph, will be of modulus of x square minus 5 modulus of x plus 6. Now this one, and we are looking at y equal to 0, means all I need to find this graph at how many points it is intersecting with y equal to 0, that is x-axis. So clearly it is again 4 points. This was already 2 and 3, and we have taken the mirror image, so definitely this one will be minus 2 and this one will be minus 3. Again we are getting the same solutions, x equal to, the same solutions we are getting, x equal to minus 3, minus 2, 2 and 3, 4 solutions. Okay, I want you to do this kind of question like this. Okay, but anyway you need to know both the methods equally. Okay, let me go for another kind of question. should be this modulus of x square minus 6x plus 8 plus x minus 7 equal to 0. How to do this? To solve this, x square minus 6x plus 8 can be written as 7 minus x, that is minus 6 plus 7. Okay, the question is find the number of solutions. Find the number of solutions of okay. Again, this question again can be done with algebraically, but I will go for the graphical way of solving it. We know how to solve, how to draw the graph of inside modulus, right? X square minus 6x plus 8 quadratic polynomial with x minus 2 into x minus 4. So roots are 2 and 4. 2 and 4. Okay. The graph will look like something this. This is the graph of y equal to x square minus 6x plus 8. But we are looking for modulus of it. So how to draw the modulus that day we have discussed? We have to discard the graph of fx lying below x-axis, and we have to take the mirror image on x-axis, right? So before we do that, let me find out this point, vertex of the parabola. We know that if alpha and beta are the two roots of a quadratic polynomial, then the vertex is given by alpha plus beta by 2. So this one will be 2 plus 4 by 2, that is 3. The value of x will be 3. So 3 comma 0. So this point, if I put x equal to 3, I'm going to get y equal to minus 1. So this point is 3 comma minus 1. So now I can draw the image. Take the mirror image of the portion of the graph lying below x-axis. Now this will be the graph of, what do we call it? Y equal to modulus of x square minus 6x plus 8. Okay, and this point being 3 comma 1, because this one was 3 comma minus 1. Now then, let us solve what this graph, left hand side of the graph equal to y we have drawn. Now right hand side of the graph equal to y we will draw. Of course, that is a straight line. When y equal to 0, x equal to 7. Let me take 7 somewhere here. And when y equal to 0, sorry, x equal to 0, then y equal to 7. So right hand side graph will look like this, and it's going to intersect this curve. This curve means the parabola somewhere. Okay, so there will be two solutions, one here, one somewhere here. So number of solutions. Again, that is how we solve this kind of questions. Again, with modulus. If somebody asks me to find the solutions exactly, what are the two solutions? Obviously, we are going to solve this. Okay, that can be done algebraically, very easy. Okay, we'll go for the next kind of question. What about this? Modulus of, suppose, solve modulus of x squared minus x minus 2 plus x plus 6 is equal to modulus of x squared minus 2x minus 8. How to solve this kind of question? Solve. This question is solve. How it is different from the rest of all? The modulus is there in both the sides, and some part of the modulus function is on quadratic polynomial and some part are there in linear polynomial. In this kind of question, we have to observe the question carefully. Let me take this one as A and this one as B. We'll try to find out, we'll try to establish one relation between A and B, plus and minus of course. We'll check whether A plus B is telling me something or A minus B. Okay? So here, if we observe carefully, find that if we subtract B from A, that is A minus B, what am I going to get? X squared minus x minus 2 minus x minus 6, that is, we'll get x squared minus 2x minus 8. So ultimately this equation is looking like this: modulus of A plus modulus of B is equal to modulus of A minus B. Again, to solve it further, we need to know a few properties. I'll write down these properties and I'll advise you to note it down, these few properties. So there are actually basically two properties subdivided into 2 and 2. So property 1, the first part, property 1, first part, it says modulus of x plus modulus of y is equal to modulus of x plus y. Then x and y x and y have same sign, or either x or y is 0. If this happens, then we'll conclude this: x and y will have the same sign, or x or y, any one of them will be equal to 0. That is what this property is telling us. Very easily it can be verified by taking two numbers. Okay, two numbers, and you verify that they have to be of same sign to maintain this equality. The second part, it says modulus of x plus modulus of y is equal to modulus of x minus y. Then x and y have opposite signs, or either x or y is 0. Okay, this is what the first property is telling us. Okay, then we'll go for the property 2. Similar property, it will come with inequality. The first part is telling us modulus of x plus modulus of y. Modulus of x plus modulus of y will be greater than modulus of x plus y if x and y are of opposite signs. What is the difference? And now it is coming with an inequality. Mind it. Modulus of x plus modulus of y will be greater than modulus of x plus y if both x and y are having opposite sign. Means if one is positive, the other has to be negative. That is the meaning of opposite sign. And modulus of x plus modulus of y will be greater than modulus of x minus y if x and y are of same sign. Same sign का मतलब हो गया, if they are positive, both have to be positive. If they are negative, if anyone is negative, the other has to be negative. This all four properties can be verified by taking some values of x and y. Okay, I will advise you to just check it out by taking a few numbers. So please write it down. So our question was this. So we are going to use this property. Okay, so let us go. So immediately what we'll get, if modulus of a plus modulus of b is equal to modulus of a minus b, our conclusion is AB is less than or equal to 0. They are of opposite sign, or any one of A or B is 0, means product will be either 0 or negative. That is what. So what was A? X squared minus x minus 2 whole into x plus 6 will be less than or equal to 0. X squared minus x minus 2 will give rise to x minus 2 into x minus x plus 1, x minus 6 less than or equal to 0. We know how to find out this one, where this expression, where it is positive, where it is negative. There comes the wavy curve method. We'll plot the critical points in ascending order. This minus 1, 2 and 6. Coefficient of x in each of the factors are positive. So we'll start with positive, negative, positive, negative. What we are looking at, the values of x which are either less than or equal to 0. That is here. Therefore, x must belong to minus infinity to minus 1 closed, because we are looking for equal to 0 also, and union 2 to 6. That will be the answer. Okay. Again, this question again can be modified like this. Find a number of positive integral solutions of. So positive integral solution, it will lie in this interval. So number of positive integral solution will be from 2 to 6, that is 2, 3, 4, 5 and 6. So that way this question can be modified. Okay, before I conclude, I will take one more question. This is a very fantastic question actually. Legendary question as they say. I'll take this question. One of the most important questions. It is important in the sense it is going to give you a lot of concept. Question is, if fx equal to y equal to 2 mod of x plus x plus 2 minus modulus of x plus 2 minus 2 modulus of x modulus, then number 1, find the number of points, find the number of points of local maximum or local minimum. Number 2, find the number of points where fx is not differentiable. Not differentiable. And third question is asked, if y equal to k, find 3k such that fx have 3 solutions. Okay. Now then, the question: 2 modulus of x plus modulus of x plus 2 minus x plus 2 minus 2 modulus of x commodulus. Okay. Actually, this question, if we go for algebraic way of solving it, it will become very difficult. Okay. So what we'll do, we'll try to draw in the graph. Okay. So to draw the graph of it, you have to find out the critical points. Of course, the clear critical points are here. 0 and 2. 0 and minus 2. But there is a problem. 0 and minus 2 are the critical points, but there is another modulus here. So what we have to do, to get all the critical points, we have to equate this part is also to 0, so that I get the critical points inside the modulus 2. So how do I do that? To get the rest of the critical points, I have to equate modulus of x plus 2 minus 2 modulus of x to 0. So how to solve this? We'll this can be written as modulus of x plus 2 equal to 2 modulus of x. How to solve it? First, open both sides positive, then solve with any one of the side as positive or negative. Okay, so that is to say, this one will give you 2. So since x plus 2 equal to 2x, or x plus 2 equal to minus 2x. Any one of the side is positive, the other side is negative, and here both the sides have the same sign, positive or negative. So we are going to get here x equal to minus 2, negative 2, and from here we are going to get x equal to minus 2 by 3. So final critical points are 0, minus 2, 2 and minus 2 by 3. So these are the critical points. Be very careful in this kind of question. This kind of question means, what is the difference in the other question and this question? All are given in modulus and they are all linear, and some part of the function is given in between another modulus. Okay, in that case we have to find out those critical points for that modulus 2. Okay, that is the learning point. Okay, now we have all the critical points. We are in a position to draw the graph. Let us do it. We'll plot all these critical points. Zero, minus 2, minus 2 by 3, 2, that's it, minus 2 and 0, yes. Okay, and we'll find out the values of y in each of these critical points. When x equal to minus 2, we'll find out the value of y from there. X equal to minus 2, we'll put x equal to minus 2, we'll get y equal to 0, that already I have solved. Y equal to, at x equal to minus 2 by 3, y will be equal to 8 by 3. At x equal to 0, y will be equal to 0, and at x equal to 2, we get y equal to x equal to 2, we will get y equal to 8. So these are the points we plot. Minus 2, 0. So this is the point. Then minus 2 by 3, 8 by 3. Minus 2 by 3, 8 by 3 is somewhere here. This point is 8 by 3. Then x equal to 0, y equal to 0, that is this. Then x equal to 2, y equal to 8. Somewhere here. Okay, now we'll join these critical points one by one. To get this. Now, to get that part of the graph and this part of the graph, we can plot any number which is beyond minus 2 and beyond 2 that side. So let me take 3 here, minus 3 here. You can take any number. Okay. So when x equal to minus 3, y will be coming 2. So I have to remove this. 2. Somewhere here. So we have got this part of the graph. And when x equal to 3, I have calculated y as 10. 10 will be somewhere here. So the graph will go like this. Okay, so the final graph is this. Now we are in a position to answer any question. Any question. Again, the first question. Find the points of local maxima and local minima. Now local maxima and local minima difference definition was if this x changes from positive to negative, that way also we can go for. But this graph is clearly showing us that this is a point of local minima, that is a point of local maxima, this is a point of local minima, and this point actually neither a point of local maxima, local minima, because before reaching this number, this point, the graph is increasing. After that also it is increasing. So f dash x in a way is not changing its sign. So it is not a point of local maxima, or neither a point of local maxima nor a minima. Okay, so this point minus 2 is a point of local minima. This is a point which is, that is x equal to minus 2 by 3. It's a point of local maxima. And this point 0 is also a point of local minima. So minus 8, minus 2 and 0 are the points of local minima, and minus 2 by 3 is the point of local maxima. The first one is over. Second part, find the number of points at which fx is not differentiable. So not differentiable means the points where f dash x, just before that and after that, f dash x will change the sign. So here, before reaching this minus 2, the slope is negative, and just after minus 2, the slope is positive. So definitely at minus 2, the function is not differentiable. Similarly, at x equal to minus 2 by 3, slope is positive, after that it is negative. It is not differentiable here also. At 0, before reaching 0, slope is negative, after 0 it is positive. What about this point? This 2. At 2, before reaching here, it is positive, after that also it is positive. Before reaching the value of 2, it is positive. After that also, so in a way f dash x has not changed its sign, so the function will not be differentiable here also, I guess. The points where the function is not differentiable. Yes, so all the critical points except 2. No, it's changing. Before reaching 2, the f dash x is given by this slope of this line, and just after reaching 2, the slope is given by this line. So the slope are different. So points where f dash x does not exist are all the critical points: -2, -2 by 3, 2 and 3. Again, this one is over. Then the third question: if y equal to k is a line parallel to x-axis, then we have to find out the value of 3k such that fx have 3 solutions. 3. Now we know that y equal to k will be a line parallel to x-axis. So if I'll draw a line like this, it will intersect the graph in 1, 2, 3 and 4 points. We are not looking for this. If I draw like here it will intersect at 2 points. I am not looking at that. We need exactly 3 solutions, means I have to draw the line such that it passes through this point, so that I get exactly 3 solutions: 1, 2 and 3. Okay, so this one will happen. That is, this is y equal to k. This will happen only if k equal to 8 by 3. That is 3k equal to 8. So this is the answer for the third. This question already asked in IIT JEE. Most probably it is in 2013 or 14, if I am not wrong. Okay. Please comment how you have got this, and to let me know whether you have liked this video or not. Okay. Thank you.